Okay, here we are on page 5, and there are some problems here that can be done in one of two ways. I'm going to show you how to do both ways. Now, normally you would do it with the calculator, but I'm also going to show you how to do it by hand because later we might have some problems where we cannot do it with the calculator, and I want you to understand how to do it by hand. Okay, so we're doing 6D. I'll teach you how to use the calculator method shown above, so we don't need to take a look at that yet. I'm going to color code these problems because, especially for you guys that have the new calculators, your graphs and your functions are color coded in the calculator, and we're going to try to use the colors that normally come out in the calculator. So do you remember that whenever we take a derivative, you start with the original function, which I'll call the blue function, and then you have the derivative function, which I'll call the red function. Remember that the red function corresponds to the red numbers of the tile during the investigation, so we want to associate derivatives with red. Okay, so when we look at this first problem, the formula or the function they give us is the blue function or the original function. And what they're asking us to do is to find the specific red tile, the derivative, when x equals 4. And there's two ways to do that. The way you would know how to do it up until now is first you would take the derivative of the blue function. So we would say derivative equals 2x minus 3, following the procedure that you've been using for the last 4 pages. And we want to evaluate this derivative specifically at x equals 4. So that means all we need to do is put 4 in for the x here, which is going to give us 2 times 4 minus 3, which is equal to 8 minus 3, which is 5. So the answer is 5. Okay? Now I'm going to show you how you would do that with the calculator. Now in this specific case, where all they want to know is the specific value of the tile at x equals 4, all you need to do is go to the calculator and put in the function in y equals like we do in 90% of our problems in math studies. X squared minus 3x. And then we are going to graph. And then we're going to do a function called second calc dy dx, which is to find the derivative of the function. But we must tell the calculator at what point we would like to find the derivative, and we want to find the derivative at the point x equals 4. So we just type in 4, and then it goes right to that part. This is the x equals 4 value of the function, and it tells us that the dy dx of the function at this point is 5. So if you picture the investigation, remember we had like one part where we had a curve, and there were tiles on the curve indicating the slope at each point that the tile was on. Can you imagine a tile sitting right here? This tile would have a red 5 on it because the derivative or the slope at this point is 5. Okay, now is this the x coordinate? No, the x coordinate is 4, but the derivative is 5. Okay, so I'm gonna check my answer, and look, it's true. That's what I had gotten using the hand derived method. Okay, let's do number 3. So number 3 has the blue function given, y equals 11 minus 2x to the 4th minus 3x cubed. We could either take the derivative and find the red function, and the derivative of 11 is 0. The derivative of negative 2x to the 4th is negative 2 4x cubed. The derivative of negative 3x cubed is minus 9x squared. Okay, and so this is our derivative function. And then if we want to find the derivative at negative 3, we just put negative 3 in for each occurrence of x. Okay, and then we just do the arithmetic and we solve for the result. Okay, now the other method, of course, is to go here and then we type in 11 minus 2x to the 4th minus 3x cubed. And we graph it. And then we're going to tell the calculator that we want to know the derivative at x equals -3. And the way we do that is we say second calc dy dx, and then we type in -3. And the answer is 135.00002. After a while, you get an instinct with these math studies problems, and you'll know that the dy dx at x equals -3 is actually 135. Okay, it's not 135.00002. It's just that when the calculator uses its method to do it, sometimes the numbers don't come out exact because it uses an estimation method instead of actually taking the derivative like you did, like you would. So like if you did this math here, if you did -3 cubed, that would be -27. You multiply that times 4, and you get -108. You multiply that times -2, you get positive 216, and then et cetera, you're eventually going to get 135 exactly here, not 135.00002. Okay, let's move on to the next page. All right, we're just doing the odds. So here it says find the gradient of the curve y equals x cubed, and so this is our blue function at the point where x equals 6. So I'm just going to do this one with the calculator. So it's going to be x cubed minus 5x and I'm going to graph it. And you can see that we're not even really graphing it to see what's going on here. We're just graphing it so that we can do the dy dx function, which is option 6. And then to get the derivative at x equals 6, we just type in 6. So the derivative in this case is 103. Okay, what about for number 7? Now see, this is especially going to help us because remember from the last couple pages, if you have something like this expression, in order to take the derivative, first I need to simplify it, multiply everything out as a, I need to say, 21x minus 12x cubed, and then I need to take the derivative, 21 minus 36x squared, right? And then I need to plug in the point x equals 1. Now, do you see they gave me the x and the y, but we don't want x and y. I'm going to write this in blue because actually this is the coordinates of the blue function, x and y. They gave us x and y, but do we need x and y? No, because to find the derivative at x equals 1, we only need the x value of 1, right? So if we put x equals 1 in here, we would get 21 minus 36, which is negative 15, right? So let's see if we get that. Now, see, the advantage with the calculator is if I put this as is without simplifying it, it'll still work. 3x parentheses 7 minus 4x to the squared. Okay, and then I'm going to graph it. And then I'm going to do second calc dy dx. Second calc dy dx, option 6. I'm going to type in 1. And I'm going to get negative 15. Actually, I got negative 15.000001, but you can see that the calculator is using an estimation method, so it's slightly off. The real answer is negative 15. Okay? Now I'm going to do just a few more of these with the calculator so you can see how you do it, but it's pretty easy, right? So now number 9. So here's the blue function, and I'm going to type it in the calculator. Instead of t, of course, I'm going to put x, right? 40x minus 5x squared. 40x minus 5x squared. I graph it, and then I'm going to do second calc dy dx, and I'm going to put in x equals 0. Second calc dy dx, number 6, and I'm going to type in 0. Okay, and the answer is 40. Okay, now there's one disadvantage to doing it this way. What if they asked me for the derivative function without putting an x equals 0? Can the calculator do that? No, it can't. So let's try to do the next one just by using the manual method, because it's an easy one. Okay, so first of all, we're going to take the blue function and we're going to make it into a red function. We're going to make it a derivative by taking the derivative of the first and the second term. The first term is 80t, and the derivative of 80t would be 80. And the derivative of 7 is 0. And oh, what do you know? Look at that. The derivative is 80, and it doesn't matter what t equals because there is no place to put in t. So no matter what value of t, y dash is equal to 80. Okay, let's do the next one. Maybe it's more fun. So the next one, we have a blue function, which is 14h cubed. We are going to take the derivative of it. It'll be 14 times 3h squared. 3 times 14 is about 45, slightly less. I think it's 42h squared. Now I'm going to plug in the value 2/3. So I'm going to plug in h equals 2/3. So that's going to be, 42 times 2/3 squared. 2/3 squared, that's 4/9, right? So it'd be 42 times 4/9, which is, I'm going to have to do that on the calculator. 42 times, and I'm going to use the vertical fraction function because I don't need to put, okay, so I'm going to do 42 times math, and then I'm going to number, and then I go to the last one, nd, and then I'm going to put in 4/9. And if I do this, then I don't need to worry about parentheses, so it's very handy. And the answer is 56/3. Okay? And if I did it with the calculator, it would probably give me the decimal value. And 56/3, if I wanted to find the decimal value of 56/3, I could do that by changing that into a decimal by using this option here, 18.67. Okay, so if I wanted to find that using the calculator, what I could do is I could go to y equals, and I could type in 14x cubed, right? Because 14x cubed is the same as 14h squared, and then I would graph it, and then I would do second calc 6, option 6, because it's dy dx, and then I type in the magic number, which is 2/3, 2 divided by 3, 18.67, just like I got before. Okay, now we're going to do the next one using the calculator. So we'll put y equals, and then we'll type in 14r squared plus 18 divided by r. And this is one of those tricky problems where maybe you don't know exactly where to put the parentheses in the fraction, and in order to avoid that problem, let's just use the vertical fraction, which we do by pressing math, number, going to the last option, nd, and then we'll put in 18 on top and x on the bottom instead of r because we always want to use x. Then we graph it. And now we're going to do second calc derivative and put in x equals 3. So second calc derivative, which is number 6, and then we type in x equals 3. And it gives us an answer of 22. Oops. We want to use red because this is a derivative. 22. Okay, next one. Only 2 more to go. We're going to put in the function, which is 7r cubed minus 8 over r. And once again, there's a fraction in there, so I think it's a good idea if we use the vertical fraction button, number, last one, nd, and then we're going to not have to put any parentheses on here. So 8 divided by x 7x cubed minus 8 divided by x, right? And we graph it. And then we're going to look for the derivative at x equals 2. Second calc x equals 2. Oh, second calc derivative, which is number 6, and then we choose x equals 2. And the answer is 86. One more to go. Okay, we're going to put this one in the calculator, but let's do this one by hand just so they can see how to do it by hand. So the way you do it by hand is, this is the blue function, and we're going to take the derivative of it so that we can put in x equals 5. So what we're going to do is, we're going to take the derivative of the first term. Instead of 6r, it's going to be just 6. The second function, I am going to rewrite this first, okay? Forget that I did that. 6r, I'm going to rewrite it as a blue function because it's still blue. 15 halves r to the negative 1. Do you see what I did there? Instead of putting r in the denominator, which is a fraction, and we don't really like fractions too much, we changed it to r to the negative 1. Now it's easier to take the derivative because we have the power rule, which tells us how to take the derivative of this, right? 15 halves. And then the r to the negative 1, we bring down the negative 1. We have r, and then we take the negative 1 and we make it negative 2 because it goes down by 1. So now I'm kind of done. But I need to simplify it a little bit maybe. So I'm going to do 16 minus 15 halves r to the negative 2. Okay? Now all I need to do is put in r equals 5 in there, and that would give me the derivative value. So remember, now I can switch it back to r in the denominator if I want to. So I'll put 16 minus 15 halves divided by r squared. Now I'm going to put in r equals 5. And see what we get. So we're going to have 6 minus 15 halves 5 squared. Now let's put that in the calculator and see what we get. We're not going to use the y equals. We only use y equals if we have an x or some variable, and we don't have one here. Oh, let's go and get the math fraction function. 15 divided by 2 times 5 squared. Enter. And the answer is 57 tenths, also known as, let's change that to a decimal. I think it's going to be 5.7. Yeah, 5.7. Okay, now let's just make sure. Let's go to y equals, and we're going to put the function in there, 6x. So I'm showing you two different ways to do the same thing. A lot of times on the IB exam, you know, the dy dx function is really handy, but they want you normally to take the derivative also. So usually on the exam, they're going to ask you to take the derivative first, and then they ask you for the value at r equals 5. So you don't get to use this function that much in real life. I'm going to put in the fraction thing. So I'm going to put 15 on top and 2r on the bottom, or 2x on the bottom. I'm going to graph it. I think it's graphing. And as soon as it graphs, I'm just going to do a second calc dy dx. So second calc dy dx is number 6, right? I can't even see it on the screen, but it doesn't matter. And then I'm going to put the r value of 5. And it tells me the answer is 5.7. Hey, what do you know? 5.7. That's what we had. Okay? So usually in the IB exam, they're going to ask you to first take this derivative, find the red function here, and then it's going to ask you for the value at r equals 5. So unless you want to give up these points here, you're not going to be able to use the dy dx function most of the time. Okay? But you know, in this exercise book, sometimes you're going to be able to. And that's it for page 6. Next is page 7. So we're done with the video.